So we're here going to describe how we could represent conceptually what are events, things that occur more or less instantaneously in time within a Vensim diagram. So commonly we're dealing with things where we could reasonably treat it as continuous flows. So we have some amount of people, or maybe we have water in a bathtub, right? And then we have some flow out, right? This is great office hours. Then we have, outflow, right? And maybe we have a mean time to flow out, something like that. I'm just emphasizing the continuous character of this. And we have water in a bathtub. And it turns out, for reasons we'll see, the formula for the outflow is just the water in the bathtub divided by the mean time to flow out. It turns out that mathematically that's quite accurate. So in other words, that's an accurate depiction. So if we say the formula for this is the value of the stock divided by this quantity, call it A, here it's called mean time to flow out, the average time it takes to flow out is in fact A, okay? And we'll have a mean time to flow out of, 10 minutes or something like that, and we'll have 1,000 liters in our rather capacious bathtub. Okay, so I'm gonna run this thing. Yeah, sure, I'll save this. Okay, we just ran. You might not have seen it, but we can go click on this, and we got the water drain from the bathtub like that, right? That's a continuous flow. Now I think what was being asked by Bahare is what if we wanted to have an event, like a drain, like we want to instantly drain something. So we have a bucket, a giant bucket, a Krugerian bucket that we could use to transport all the water out, or somehow we could cause a trap door to open and everything drops, right? Okay, so how could we do that? Okay, this would be instant drain, right? Something like that. Okay, so you'll notice I do this with a measure of trepidation because this isn't beautiful, but yeah, sure. I wanted to I want to say, let's suppose this thing drained totally at time 10. We'll have this thing drain at time 10. You want to do that? Yeah. Okay. Okay. You'll notice, by the way, this is for those new to Vensim, I put in this new flow, and it's saying, hey, something's wrong here. It just wants me to check the equation. So is this correct, that this is going to be the integral of minus outflow and minus instant drain? Yeah, sure. Okay. Okay, now, this could be a formula for instant drain. This formula just ain't going to be pretty. In order to write the formula, I actually invent some PLE. I need to connect this to this, because it's going to be picky. It's going to require me to refer to water in a bathtub. So, ladies and gentlemen, if I want to specify the formula for a flow, what are the units of that formula? So, I'll just tell you here. Suppose these are liters, we want to set the units for time, say, to be seconds. Okay, fair enough. Okay, okay. For the instant drain, what are going to be the units associated with that? In other words, if I say instant drain is value of 1,000, what is it going to be per second? Yeah, yeah, okay, good. So it's liters per second, dimensions of volume per time, per unit of time, right? Okay, so what formula could we give that will suck it all out at that time? How much water do we have to suck out? We want to suck it out in whatever the time step of the model is. Okay, so water in the bathtub at that time, that's the amount of water we have to suck out, and we have to suck it out within the current time step. And ladies and gentlemen, there's actually a variable called time step, which in the full version of Vensim, it actually allows you to just type in here, but it's going to be an unhappy camera time step. It's going to say, I don't know what to do. Okay, fine. So let me just see if you could do this in Vensim PLE. I'm going to create, yes, I'll do it with a shadow variable. It's probably the best way. So there it is. Look at that. Shadow variable. And then we can hit this up there. So Vensim is kind of painful. It does. I mean, Vensim PLE doesn't allow you to just type it like the full Vensim does. So now we have divided by time step. Okay, time step is listed there. We could have just clicked on it if we wanted to. Okay, so ladies and gentlemen, I'm going to run this thing now. Okay, now an interesting thing's going to happen, I think. But let's run this and boom. Now what happened? Okay, value. Okay, yeah, we want to do it at time 10. Thank you. We didn't want to just do it instantly. Thank you. So, your name again? Sarah. So, we want to do this at time 10. So, we don't want it to drain like this all the time. We want to do if, then else, time equals 10. So, in order to refer to time, we have to go to appease Vensim. We have to go use shadow variable here and create a time, right? And then we can hitch this up. There it goes to time. Okay. So we want to do if then else. This is actually a function. Okay. Time equals 10. Then we do this. Otherwise, it's 0. At other times, it's going to be 0. Okay. Let's run this now. Okay. Now we've run it. Okay. Let's go see the amount of water in the bathtub. There it goes. But why does it go negative here?
Because there is instant rain and outflow.
There's already an outflow from there. And so that's already draining it. And so here we have this drain going on, and it's draining everything from here. This guy has already claimed, it's already flowing out. And so okay, so there's two options here. One thing, we could have this instant drain take into account how fast it's flowing out here and sort of discount that from it, right? Okay, so this would be one option to do it. Yes, you could give it the same if then else and make it 0. Otherwise, you could make it, okay, it's going to be taking this water out at this rate minus the other rate, this other outflow, this normal outflow, right? Okay. Yes. And here we go. And there it's just about perfect. So it's going down to something very, very close to this, and I think what we're dealing there is round off error, actually, round off error between these two. By the way, you notice these are dimensionally consistent. Here we have the amount of water in the bathtub divided by time step, so that's liters per unit time minus this other outflow, which is per unit time. Now that's option 1, right? So this will be instant drain. This will be in this other folder here, so we'll put it in 858 fall 2013, and this will be models. This is like the single ugliest model I've made in a long time, but so this will be instant drain option 1. The other possibility is, yes, Kurt, we could, as Kurt suggested, we could delete that arrow. We could get rid of this sort of little thing here, and we could basically, at that same time, we'd have to connect these guys up to it, and at the same time basically suppress this outflow. Now, personally, I like the first. If I had to do one of those options, I'd do the first option, because it involves just keeping the ugliness to a single place. It's sort of a principle of separation of ugliness. let's do this here. So if time equals that, the outflow, then if time equals that 0, otherwise we'll have this. So in other words, at this time equals 10, the water outflow from here along this line is suppressed. Otherwise, it's water in the bathtub divided by mean. Okay. Hey. Oh, okay. It says I'm not using time step. Oh, that's true. I don't need time step. Oh, come on. Yeah, this is a pain. Okay. So boom. And yes, Bahra. Yes. Well, you were asking, as I understood it, how do we capture events, like an instantaneous event? And this can capture an instantaneous event. It's essentially occurring in a single time step. You are setting the flow, so this is the option 2. You're setting the flow to be such that it will drain within a single time step. This instant drain, we are manipulating things so all the water flows out in a single time step. Just like you can withdraw all your bank account in a single instant, conceptually, this can occur in a single time step. I was just showing how you could do that in Vensim. It's a little bit unusual, but it's not hugely unusual. I've seen probably 20 models like this over the years where they use this, maybe 30. So I see it. It's just it's not something you do day to day typically, but occasionally it's nice to kind of force it so it instantly gets rid of that stock for an experimental reason or something. You want to see what would happen if this, and you can do it. It's just it's unusual because normally we're simulating processes in system dynamics where there's more or less continuous change, and so we could treat them as flows rather than as an event which occurs in an instant time and instantly sort of updates the stock. And that's what made me uncomfortable with the bank account, because conceptually we're dealing with kind of an instant in time when we withdraw something from that bank account. And so the analogy of a stock, or of a flow, excuse me, where we say it's 100 liters per second, and therefore in half a second we have 50 liters, and in a tenth of a second we have 10 liters. That kind of breaks down when you're dealing with bank account where it's an instant transaction. And I was just showing how you could do that in Vensim, but it ain't pretty. It's actually much, much nicer to do in system dynamics in any logic. You don't have to do it this way. It can be precise and done quite elegantly. You could set an event, the event goes off, you totally drain the stock. You don't have to force it as if it's a flow out with a super fast rate or anything, okay? So we'll see in any logic it's much more natural, because any logic is a much more general mechanism for scheduling, for handling events as well as continuous flows. Okay? Okay. So those are some comments, and we'll see if we can come back to this. Remind me if I forget. Come back to this with any logic.